This video is on the next method of solving a system of equations, and it is known as the elimination method. What we have here, it tells you a little bit about how this method works or why it works at the top of your document here. That's for you to read on your own. Go ahead and read that, and you can see why we're doing what we're about to do. But let's get into the action now with example B, part A. We have a system of equations where one is 4x plus 3y equals 14, and the other is 3x minus 3y equals 13. Now, what we want to do is we're going to go ahead and notice that with the y's, one is a positive 3y and one is a negative 3y. This problem is set up automatically for elimination because the two y variables have the same coefficient, 3, but they're opposite. One is plus, one's minus. One's positive, one's negative. So when you combine the two equations together, which I'm about to do, we're going to go ahead and add the two equations together. So we're going to add the x's together. 4x plus 3x is 7x. This is known as the elimination method because in the next box, when you add the y's together, okay, we're going to do a positive 3y plus a negative 3y. And just imagine what's going to happen there. Positive 3y and negative 3y, when you add them together, they eliminate. They produce 0, so they are gone. On the other side of the equation, we have 14 plus 13, which is 27. And now we have a nice simple equation to solve by dividing both sides by 7. Divide both sides by 7, and you get x equals 27 sevenths. That's a decimal. We'll round that to 3.86. Once you know the value for x, you will plug 3.86 back into one of these equations for x and solve for y. I'm going to let you go ahead and do that yourself and go ahead and find the y value. So again, you're going to do 4 times 3.86 plus 3y. I'm choosing the top equation just because it's convenient, equals 14. Go ahead and solve that equation for y and see what you get. In equation B, or example B rather, this one's a little trickier because if you look at the y values, they are not immediately set up for elimination. What I mean by that is if we focus in on the x's, one's negative 3x, one's positive 2x. If you add those together, they do not eliminate. The other is positive 5y and positive y. If you add those together, they will not eliminate. So you have a couple of options here in this system in order to get either the x or the y to eliminate. And it has to do with multiplying through by a constant. We can always multiply both sides of an equation by the same number and keep it balanced. So what I'm going to do is I'm going to focus on the y's, and I'm going to get them to eliminate. One is positive 5y. The other one's just positive y. If that positive y on the bottom would be a negative 5y, then we would have the elimination that we want. The positive 5y and the negative 5y would cancel. So what we're going to do here is we're going to leave the top equation alone. Go ahead and write that down in your paper. The top equation is staying put just the way it was. But the bottom equation, we're going to take every term in it and multiply by negative 5. So 2x, we're going to multiply by negative 5 and get negative 10x. Positive y, we're going to multiply by negative 5 and get negative 5y. And then on the other side of the equal sign, very popular mistake to forget about that 6. That 6 has to be multiplied by negative 5 as well to get negative 30. So again, we kept the equation balanced because we multiplied both sides by the same number. It's just we made it look different so that now when you look up and down in these two equations, we have a plus 5y and a minus 5y. So when we add them together, they're going to eliminate. So let's go ahead and add the x's together. Negative 3x plus negative 10x is negative 13x. Positive 5y and negative 5y will eliminate. 6 plus negative 30 is negative 24. And we're ready to solve by dividing both sides by negative 13. So we're going to take 24 divided by 13, and we get the x 1.85. That's the approximate solution for your x. Again, now that we know our x, we still need to find y, so you're going to plug it in either for that x or the x in the bottom equation. It's up to you. In this one, I might choose the bottom equation, 2x plus y. There's a little bit less going on there. There's no negative. The y is by itself. It'll be pretty easy to solve and find the y value. So go ahead and finish that example and bring your answers for y for both equations into class tomorrow, and we'll just sort of compare answers and see how you did. We'll talk a little bit about this technique known as elimination in the other video, substitution, clear up any questions, and then get started on the problem solving. As I mentioned in class and on Dashboard, I am going to create a small quiz for you to take. It should take only about 2 minutes for you to answer a few questions about both of these videos. Please check your Gmail, student Gmail, to get the link to that survey. Thanks.